Imagine I were to throw this ball. Notice how it slows down at the end of its path? What if it actually sped up? While that might sound impossible, that's actually what happens in space when a spacecraft goes near a planet. This is also NASA's secret to saving fuel. And it's called a gravitational slingshot. And I want to see if we can actually simulate that. But I'm not exactly the greatest coder, so... But that's okay, because thanks to a tutorial from Tech with Tim, I was actually able to build a simulation that shows a spacecraft just whipping around Jupiter. So let's actually go through the code. Over here, we have Pygame. We're using Pygame for the visuals and the animation because without it, we don't get to see anything. And then we use math for all the angles and the distance and all the calculations because we're using physics. So obviously we need math. This is just the window, like it creates where everything is drawn in. Over here we have our constants, like the planet's mass, the ship's mass. G is the gravitational pull. FPS, you guys know what that stands for. And the size of everything, like the planet, the spacecraft, and then how strong the initial velocity is. Oh, this is fun. It's not that much, but this just loads the visuals. Like we can actually see a space background and the planet. These are just color values for drawing things. And over here, we actually have our planet, Jupiter. And what this does, it just stores where the planet is and draws it on the screen. This over here is the complex stuff. It's our spacecraft, because that's the only thing that actually moves in our simulation. So over here we have the ship. It just creates the ship with a position, velocity, and mass. And then here's like the movement of it. And it actually uses real physics formulas, like the distance formula, the Newton's law of gravitation, and then it finds the angle from the ship to the planet. I'll explain the physics behind it later, but for now we'll just go through the code. So generally this whole section is just the physics engine. It calculates gravity pulling the ship, it updates the speed, and moves the ship accordingly. This just draws the spacecraft as a dot. And over here, essentially what this does is when you click and drags, it changes your second click to your direction and velocity. I'll show you guys after, you'll know what I mean. So now we're on to our final section, which is the game loop. So what this means is it just keeps our game running at 60 FPS. And then over here, this just means when you first click it, it'll place the ship. And then the second time you click it, it'll launch it towards that second click. This just shows the line of your direction, it's gonna launch at. And then over here, if you launch it towards Jupiter, it's gonna get sucked in, so it just removes it off the screen. Or if you aim it off the screen, it's gonna disappear. And then finally, when we close the window, the program exits. So now that we've went through the code, let's actually see how this thing works. Okay, so this is Jupiter, and then this is outer space. Yeah! Okay, so now you see this red dot, right? That's supposed to be our spaceship. And this line is gonna judge where it's gonna go. So if I were to throw it over here, it's gonna go over there. But look, when I put it near Jupiter, watch what it does. Isn't that cool? Oh my god, okay. And then look, if I do it too slow, look, it's just gonna get sucked into Jupiter. And that is gravity. So look, let's do it again. Let's do it a couple of times so you guys can see how it actually gets a speed boost. So over here, oh, that was too close. Look at that. That basically gave a free speed boost. And then that. Let's do it a bit further. Oh, no, okay, that's the sweet spot. Over here. Let's do one more. This one's gonna be the best one. Okay, I don't know if that was the best one, but that was good. So now that you guys have actually seen it, let's see the actual physics behind it. But for that, we gotta go to the whiteboard. So why does it actually speed up? What does gravity do? So first, we need to find the radius. So let's say this is Jupiter, right? And use another marker. This is our spacecraft. So gravity actually pulls these two together. It's not just this planet right here pulling this. They actually attract each other. And so to calculate this distance, the way we use it in our simulation, we actually got our x component and then our y component, and then just found our hypotenuse using like the Pythagorean theorem. So this leaves us with the radius. Remember that, okay? Now, once we know the distance, we can calculate the gravitational force. Let me show you guys the equation. So this force depends on three things: the planet's mass, the ship's mass, and the distance between them. And this g just represents like the pull of gravity. So if you were to double the distance, that means you'd have a quarter of the force. So here's where it gets cool. This is Jupiter, right? And this is our little spacecraft. As it gets closer to our planet, gravity actually speeds it up. So that's why it starts curving, because it starts pulling it, obviously. And then because of inertia, it keeps going at that speed. And it gets a free speed boost. That's basically the physics behind it. And yeah, that's basically it. That's a gravitational slingshot. I'll put a link to the video by Tech with Tim in the description if you guys are interested. But anyways, thanks for watching. I'll see you guys in the next one.